While scripting with large lists in Dynamo, we often need to perform a single function for every item in a list. Say for example, we have a list of numbers, we may want to create a list of points based on those numbers driving the x-coordinate. To do this in Python, we need to learn about a programming concept known as looping. Looping allows us to execute an instruction repeatedly until a certain condition is met. Say we've looped or iterated through every item in a list. There are two types of looping in Python, the for loop and the while loop. Let's start by looking at the for loop. Say for example, we had a list of numbers, 0 through to 5. A for loop will allow us to loop over every item in the list and perform an instruction. To do this, we need a variable, say var for example. And for each loop through the list, the item is assigned to the variable. So looping through our list of numbers, in the first loop, var would equal 0, in the second loop, var would equal 1, and so on. This will continue until every number in the list has been looped over. So let's jump back into Dynamo and learn how to create a for loop in Python. In a new Dynamo file, let's place and open a new Python script. To begin the for loop, we'll need a list to loop over, such as the list of numbers. So let's use the range function, which we learnt in an earlier video, to create 10 numbers and assign it to a variable named lst. Now to start the for loop, we need to use the keyword for, followed by a variable name such as var, followed by the keyword in, and then the list that we want to iterate over, lst in our case. As this is a statement, we end the line with a colon, and then enter and tab in once. Within this indent is where any instruction we want to execute for each loop will go. For our first for loop, let's see what happens if we simply append the var variable to a list. So before the for loop, let's create an empty list named output, and then within our for loop, let's add output.append var. So we are looping over each number in the lst list, and for each loop, we are temporarily assigning the number to the var variable, which is appended to our new list. So let's output lst and output together to see what we get. And hit run. Great, so you can see that both lists are the same, as we have looped through the first list and simply added each item to our output list. Now let's have a look at using the for loop to create geometry. So let's clear our output list by reassigning it, and then start another for loop through the lst list. This time, we're going to loop through each of the numbers and use each one to drive the x-coordinate of a point. So let's create a new variable named point within our for loop, and we'll assign to this a call to the byCoordinates method using var as the x-coordinate. Then append this to our output list and hit run. Perfect, so it looks like our loop has created a series of points. If we look in the Dynamo graph, you can see that we have 10 new points. With each loop of the for loop, the var variable has been used to set the x-coordinate of each point we are creating. Let's try one more loop exercise. As we have just learnt, anything we write after the for loop and within the indent will be executed with each loop. This can include anything, even the if-else conditionals, which we learnt in an earlier video. So for example, we can check if var is a specific number and create a point based on the result. Let's try adding a conditional statement within a loop. Start by reassigning the output list to clear it, and creating another for loop over the lst list. For each loop, let's check if the var variable is greater than 3, and if so, create a point. To do this, we'll use an if statement. And then within this if statement, create a point variable, which will create a new point by coordinates with var for the z coordinate. And then hit run. You can see that we don't have our points in our list because we haven't appended point to the output list. So go ahead within the if statement, append point to the output list and hit run. Great, so there's our points. And you can see in the dynamo graph, they only commence at z equals 4. For loops are not only used to iterate over lists of numbers, they can be used to iterate over any list of objects in Dynamo, including points, curves, or Revit elements.